Hey people, so today we're working on 7.3. We're going to do some modeling with exponential functions. And all modeling means is try to use a situation to come up with an equation so that we can then make some estimations about whatever we're talking about. That's all that modeling is. So some new vocabulary that's not really new. Exponential growth function. When it's growing, it just means it's an increasing exponential function. It's just going up. Like the bacteria population is growing. A decay function is what I don't want my money to do. It is a decreasing exponential function. So maybe like, I don't know, something that goes down pretty quickly over time. Alrighty. So let's give this a shot, and we're going to use some of the tools in your calculator that we've used in polynomial functions. So if you ever are not quite sure how to do something, we did it more in detail back in polynomial functions, so check that out. The population of Canada from 1921 to 1971 is shown in the table below. So here's the year, here's the population, it's clearly going up, so this is increasing. Determine the equation for exponential regression that models the data. Okie doke. So what I need to do is I need to be able to tell my calculator these values, and then I have to ask it for a regression equation. Remember, the regression equation is just like a line of best fit. It's just like what equation kind of matches the data. So let's first start off by putting these values into our calculator. Start by turning her on, and we put these into the lists. So reminder, we go stat and 1 or enter, and then I want to clear this stuff I have in here, so I go up to the top, hit clear, enter, up to the top, clear, enter, and then we type them in. So enter values, go stat, and then 1 for edit, and put in whatever you have in there. So let's type those in. Alright, I should also mention which one should be our x and which one should be our y. So remember, if there's ever time involved, that's always x. And if time's not involved, I usually try to think of like what comes first in the situation. So this is our x and that's our y. So that's going to be list 1 and list 2. And I have it entered in here. Now, just like how we've done this before, be really, really careful we type this in properly, because one little decimal wrong and you're going to get a different answer than I will. So we have to be really, really careful that we do this correctly. Now that we have this in here, we can actually find the regression equation. So step 2, equation. You can exit if you want to, you don't have to exit, but we're going to go stat, we're going to go over to calc, and then we're going to pick one that feels like it matches what we're trying to do here. So this is exponential, which they told me, and I'm going to kind of go through my list here and try and find one that says exponential. Oh, look at that. 0, exponential regression. So I went stat, over to calc, and then 0 for exp reg. You know, they give you hints. Like it's pretty good. It's a good name for it, right? And you can either hit 0 or you can hit enter on that. You might have to hit enter again or more than once, you know, whatever you got to do. Alrighty, so here's my regression equation. Here's my answer. So we're going to write it in just like the form it has right here. So A is 5.55, E negative 15. Now that E is actually scientific notation, and when it's a negative number like that, it means it's very, very small. Now this E negative 15 is actually pretty important, so we need to write that down as well. 5.55 E negative 15. That's all we need to write for it. You can change it to scientific notation if you want. It'd be times 10 to the negative 15. It doesn't really matter. And then my B value, 2 decimal places here, 1.02 to the exponent x. So that's my answer for the first part here. Let's try the next thing. Determine the estimated population in Canada in 1967, the last time the Toronto Maple Leafs won the Stanley Cup. Round your answer to the nearest million. Okie doke. So, 1967, is that an x value or a y value? I'd say that's an x value. So when I have an x value and I want a y value, well, first I'm going to have to graph this thing. So let's graph this. So step 1, graph. Now, I need to have this on my screen right here. I don't want to clear that out because I want to take this, copy and paste it, so I have all the decimal points, so it's a perfect graph, okay? So we're not going to clear it. And if you do clear it, you have to go through those steps up here again. So I'm going to go to y equals, clear all the stuff I had in here somehow. I don't know how I managed. Oh, okay, different calculator. Now I want to copy and paste. So copy and paste, we hit vars down here, vars. 5 for statistics, we go over to EQ and 1. And then you'll notice it copies and pastes it in with all the decimal places, which is perfect. So we go to y equals, we go vars, let me check for this again here. 5 for stats, we go over to EQ, and then 1 for reg EQ, regression equation. Okay, so that just kind of copies and pastes it into our graph right here, which we can then hit graph to take a look at. And you know what? It doesn't look like anything's popping up, and that feels like I did something wrong, but we have to remember that almost always we're going to have to change our window settings. Now, what's nice about this particular question is that it gives us a bunch of values. So it gives us an idea of what my window setting should be like. So my X, it's going to have to be at least 1920 and go up to like bigger than 1970. And my Y should maybe start at like 0 and go up to like 30. So let's adjust our window settings here. So a little smaller than 1921 for X, so maybe even like 1900, going up to maybe 2000. And we'll go up by like 100s perhaps. So what should you count up by, right? Oh, 2000, not 200. Whoops. Okay. Y min, okay. It started at 8, so let's start at like 0 maybe. And let's go up to maybe 30. And we'll go up by 5s perhaps. Give that a shot. And there we go. And you can see the exponential curve. If I zoomed out a bit, if I showed a little bit more on the graph, you'd see that curve even more. But this is good enough for us. So number 1 is graph. Number 2 is adjust window settings. Now that we have this done for the next question, we don't have to do this again, which is nice. And then step 3, we actually want to find the answer to this question. So they told us X is 1976. So we want to find a value on our calculator. So to do that, we're going to go second trace, 1 for value. It asks me what is X. I'm going to tell it 1967. And it tells me 19.6416, whatever. So 19.64. They asked me to round to the nearest million, so 20 million is my answer. There was a lot of steps to do one thing, right? But really, this is the part that we're doing for the question. This is just the part that we're doing for the setup for the question. Let's try the next one here. Assuming that the population growth continued at the same rate to 2015, so it just kept going, estimate the population in 2015. Round your answer to the nearest million. Okay, 2015 is an X or a Y value. It's still an X, which is great because we're going to use the same kind of ideas right here. Let's give that a shot right now. So second trace, 1 for value, 2015, and I get an error. But remind myself, I only went up to like 2000 here, so I just can't see it on my graph. So we need to tell the window to go up a bit more. I need to go up and maybe even to the right a bit more to see more of this, okay? So if I want to go up, that will be my Y max. So instead of 30, let's make it like 50. And my X max only goes up to the year 2000. I definitely need to go more than that. So maybe even 2020, today's year. Let's try that. So I graph it. The graph is going to look very, very similar. And then we can try this again, finding that value. So second trace, 1 for value, 2015, and now we get a value. So sometimes there's a little bit of guess and check with that, and that's totally fine. I got 47.6, nearest million, 47 million people. I have no idea if these numbers are right or if they're made up, but you can find that out on your own. Let's see what's on the next page here. All right, beautiful. Let's give this a shot. This is a great time to pause and try on your own, by the way. This would be a really good idea. And you'll notice we're not really using new concepts or new tools or anything. Everything's exactly the same as polynomials, except that our characteristics are a bit different, and we're using expreg instead of quadreg, right? Like that's the only difference. So we're just adjusting what we're doing. We're not learning brand new topics. Okay, let's try this. In the family studies course, Mallory, Erica, Bryn, and Kat baked a vegan lasagna. Why is it vegan? I don't know. That's a different problem. Once it was finished cooking, they had to let it cool before they began eating it. Erica read that to avoid burning the top of your mouth and tongue, you should wait for it to reach 45 degrees Celsius. The following table is a record of the lasagna's temperature. Construct a scatter plot of the data. Okay, what's going to go down here? That's the independent variable. That will be our time. So let's throw that on there right now, time. I need to go from 0 to 30 at the very least, so I think I'm going to go up by 5s. 5, 10, 15. Kind of squish myself in there, but I'll go up to 35. It doesn't perfectly use the graph, but it's pretty good. Of course, assuming you can read my writing, because you know that's always a problem. So I went up by 5s along the bottom, and then temperature, temp, degrees Celsius. We have to say the units, and actually I should say the units down here as well. Now for temperature, my biggest temperature is 90, and my smallest is like 38, but I'd like to start at 0 whenever I can, because, you know, at some point, well, I guess you'd have to put it in like a fridge for it to get to 0 degrees, but it will keep going down with this regression. So let's go from 0 up to 90, and I think I went up by 10s this time, just because that seemed to fit pretty well. Yeah, beautiful. And then, you know what, that actually gives us 2 marks out of 3. Like if this was a question on an exam, this would be out of 3 marks. You would have gotten 2 marks for doing that. The third mark will be our dots, and if we have to put a line on it, that'll be part of our line as well. Alrighty, so let's put some dots. At time 0, temperature is 90, so right up here. Now we're not going for perfect, we're going for a good estimate of where these dots should be. It's really not measuring, I'm just kind of guessing where it should be. I generally do not suggest you do this in pen, and I hate doing it in pen myself because I tend to make mistakes. Now it's not quite linear. You can see there's a general, like a real gentle kind of curve right there, and it will keep curving. It's just it's kind of barely a curve, but it will start to curve. So construct a scatter plot. Done. Determine the equation of the exponential regression that models the thing. So I have to tell my calculator those values. I'm going to exit this graph that I had going, clear anything else I have on there. I need to enter in these lists. So stat, 1 for edit, clear all the junk I had in there by going to the top, hitting clear and enter. X is my list 1. Temperature is my list 2. What did I do here? Here we go, I got stuck for a second there. Okay, list 2 is my temperature. Being really careful that I don't type something in wrong because it's so frustrating, and then, you know, it's hard to see exactly where you get your answers. So I typed them all in, now I want to find that regression, so I'm going to go stat, over to calc. I'm going to search through this list here. Oh, expreg, that's the one I want. Might have to hit enter, and there we go. Y equals 2 decimal places, 90.29, then my b value, 0.97x. Beautiful. After how many minutes will it be safe to eat the vegetarian lasagna? Okay, well they told us at 45 degrees it'd be safe. So 45 degrees it's safe. Is 45 degrees an x value or a y value? I'd say that's a y value, right? So this time we need to do something a little different to find what the x value would be. It's kind of more annoying. We need to graph the equation. Let's do that real quick. Graph the equation. So with this on my screen, I'm going to go to y equals, clear any other junk I have in there. I'm going to copy and paste. So vars 5 over to EQ and 1 or enter. It copies and pastes it. Great. Graph the equation. And then we need to graph this line as well. And then y equals 45. Remember, this is review, so if this is totally new to you, go back and look at the polynomial stuff. Y equals 45. I'm going to have to adjust my window settings, I can tell that. But since I've already made a graph, I'm going to make my window settings exactly the same as my graph. So x is going to go from 0 to 35, going up by 5s, and my y values are going to go from 0 to 90, going up by 10s. So what's nice about doing the graph, first of all, is that you can really see it, right? And you can see it does have that really slight curve, and then there's that other line on there. And now we want to see where those two lines intersect. So we go second trace, 5 for intersection. And then I think we have to hit enter 3 times, but I can't remember that exactly. So let's try it. Enter, enter, enter. Yeah, 3 enters. And then there's our value. So enter times 3. And here's my value. So when it's at 45 degrees, it has taken 24.46 minutes. Exactly the type of question you would have gotten in polynomials, right? What will be the temperature if they waited 40 minutes? Well, that's an x value, which is great because I don't really love doing the intersection thing. I'm just going to get rid of that second line, so I'm going to clear that, just so it doesn't kind of get in my way. And I have to make sure my window setting is big enough to see that value, or else I'll get an error, which is, you know, not ideal. So I'm going to make my window setting a little bigger. I'm going up to 35 right now. Let's go up to like 45 just to be safe. Go back onto there. Now to find, when I know what the x value is and I want to find the y value, we go second trace, 1 for value, x is 40, 28.91 degrees Celsius. So we're going to make sure we have those units on there, and then we are all done. Alrighty. One more. This is an old exam question, and then we will call it quits for today. Okay, last one. Given the equation y equals 400, 0.9 to the x, describe what 400 could represent in a real life situation. So this is where we do need to know what that value represents, and then we have to kind of be able to connect it to real life situations. And it doesn't have to be real life, like I'm putting quotation marks around real life, you know what I mean? It's not actually something I'm doing, it's just what it could be in our actual world, not just our math world. So if you remember, this is ab to the x, a is the y-intercept. And then 0.9 says decreasing, right? Because it's smaller than 1. So this is going to look something like this. That's 400. It's going to go down like that. So let's try and just brainstorm something that could start at 400 and decrease. So for example, maybe like a bacteria population that is decreasing. Or maybe you had your money in a mutual fund that was not doing so good and it was losing you money. Or maybe it is number of people who signed up for a sports league when they found out, and then they found out that the sports league was actually embezzling money and everyone tried to get out of the sports league and it was going down. You know what I mean? Like anything really works in here. I want you to reference why we start at 400 and why we're decreasing. So bacteria population starts at 400 and decreases because, I don't think you have to say because, it decreases. It's bacteria. It's being killed off by something. Alrighty, and that is it for today. I'm just going to come up with some homework questions for you, and then we'll give that a shot. Alrighty, and here right at the top is some homework questions. Give those a shot, see how they go, make sure you practice what you're doing. And when in doubt, write down the calculator buttons you're using, so that way when you look back at it later, you can always remember what you're doing. Alrighty, otherwise have a good night, and I'll talk to you later.